Imagine holding something so small that you cannot see it, cannot feel it, cannot even properly picture it, and yet inside it lies enough energy to change the fate of the entire world. Not a mountain, not a storm, not a star, just a tiny atom. Now here's the strange part. For most of human history, we believed this little thing was simple, solid, and unbreakable. We thought we had reached the end of the story. But what if I told you that this end was actually the beginning of one of the most shocking discoveries ever made? Because the moment scientists dared to ask a deeper question, what's inside the atom? Everything changed. Reality itself began to crack open. The solid world turned out to be mostly empty space. The quiet atom revealed a violent, restless heart, and hidden inside that heart was a power so immense that once released, it would light cities and level them. This is not just a story about science. It's a story about curiosity that refused to stop, about minds that pushed beyond the obvious, and about a discovery that gave humanity something it had never held before, the ability to reach into the core of matter and rewrite it. But with that power came something else, something far heavier than equations or experiments. So the real question is not just how scientists split the atom. The real question is, what happened to us when they did? Stay with me, because by the end of this, you won't just understand how the atom was split. You'll see the world and humanity itself in a completely different way. It begins with something so simple that it almost feels insignificant. A question. Not a grand, dramatic question, but a quiet one that slips into the mind and refuses to leave. What is everything made of? For centuries, people believed atoms were the smallest, indivisible pieces of matter, tiny solid spheres forming the foundation of reality. But curiosity has a strange way of refusing to accept comfortable answers, and scientists like Ernest Rutherford were not satisfied with the idea that the story ended there. They wanted to peek behind the curtain, to ask whether the atom itself had a structure, whether it hid something deeper. When Rutherford and his colleagues performed their famous gold foil experiment, firing tiny particles at a thin sheet of gold, they expected those particles to pass through almost undisturbed. Instead, some of them bounced back as if they had struck something incredibly dense. That moment shattered the old picture of the atom. It revealed that most of the atom is empty space, with a tiny, massive nucleus at its center. Imagine realizing that everything you can touch, everything solid around you, is mostly emptiness. That realization alone is enough to change how you see the world. Once the nucleus was discovered, the question shifted from structure to power. What is hidden inside that incredibly small, dense core? The answer was both thrilling and unsettling. The nucleus is not just a passive center. It is a storehouse of energy so vast that it defies intuition. Scientists began to understand that the forces holding the nucleus together were unlike anything seen in everyday life. These forces were immensely strong, binding protons and neutrons tightly, despite the natural repulsion between positively charged particles. The idea slowly emerged that if one could somehow disturb this delicate balance, the energy released might be enormous. This was not the kind of energy you get from burning coal or oil. This was something deeper, something tied to the very fabric of matter itself. The atom, once thought to be a simple building block, was now revealed to be a locked vault of energy, waiting for the right key. Finding that key was not easy. It required not just theory, but bold experimentation. In 1932, two scientists, John Cockcroft and Ernest Walton, built a machine capable of accelerating particles to high speeds. They used this machine to bombard lithium atoms with protons, and something remarkable happened. The lithium nucleus split apart, transforming into two smaller nuclei and releasing energy in the process. This was the first time humans had artificially split an atom. It was not an accident of nature, it was a deliberate act. For the first time, humanity had reached into the heart of matter and changed it. The significance of this moment cannot be overstated. It proved that the nucleus could be manipulated, that the immense energy within atoms was not just a theoretical idea, but a practical reality. It was as if a door had been opened, revealing a vast and powerful new landscape. But even this achievement was just the beginning. The true breakthrough came a few years later in 1938, when Otto Hahn and Fritz Strassmann conducted experiments that led to a puzzling result. They bombarded uranium with neutrons and found that the products of the reaction were much lighter elements, such as barium. This made no sense under the existing understanding of atomic physics. How could a heavy atom like uranium break into much smaller pieces? The explanation came from Lisa Meitner, who realized that the uranium nucleus had split into two roughly equal parts. This process was named nuclear fission. What made fission extraordinary was not just the splitting itself, but the fact that it released additional neutrons. Those neutrons could go on to split other nuclei, creating a chain reaction. Suddenly, the idea of releasing enormous amounts of energy was no longer hypothetical. It became clear that under the right conditions, a single event could trigger a cascade, releasing energy on a scale never before imagined. At this point, the story takes a turn from pure curiosity to profound consequence. Scientific discoveries do not exist in isolation. They are part of the world, influenced by its tensions and conflicts. The discovery of nuclear fission occurred at a time when the world was on the brink of war. The realization that a chain reaction could produce an immense explosion quickly attracted the attention of governments. This led to the Manhattan Project, a massive secret effort to harness nuclear energy for military purposes. Scientists who had once been driven by curiosity now found themselves working under intense pressure, racing against time. The result was the creation of atomic bombs, weapons of unprecedented power. When these bombs were used during World War II, the world witnessed the destructive potential of nuclear energy. Entire cities were devastated in moments. The splitting of the atom, once a purely scientific achievement, had become a force capable of reshaping history. Yet the story does not end with destruction. The same principles that make nuclear weapons possible also make nuclear power possible. The energy released in fission can be controlled and used to generate electricity. Nuclear power plants harness this energy to produce large amounts of electricity without the need for fossil fuels. This dual nature of nuclear energy highlights a fundamental truth about knowledge itself. The splitting of the atom is neither inherently good nor inherently bad. It is a tool, and like all tools, its impact depends on how it is used. This realization forces us to confront a deeper question about responsibility. When we unlock the secrets of nature, we gain power, but we also take on the responsibility to use that power wisely. What makes this entire journey so remarkable is not just the discoveries themselves, but the way they unfold. Each step builds on the previous one, driven by curiosity, experimentation, and the willingness to question assumptions. The idea that atoms are indivisible gives way to the discovery of the nucleus. The nucleus reveals hidden energy. Experiments show that this energy can be released. The discovery of fission reveals the possibility of chain reactions. And finally, these insights lead to technologies that can both create and destroy on a massive scale. It is a story of human ingenuity, but also of human complexity. If you look closely, you can see that the splitting of the atom is not just a scientific milestone. It is a mirror reflecting the nature of human progress. We are capable of incredible insight, of uncovering the deepest secrets of the universe. At the same time, we are capable of using those insights in ways that can have devastating consequences. This duality is not unique to nuclear physics, but it is especially stark here because of the scale of the impact. The energy released in nuclear reactions is so vast that it forces us to confront the consequences of our actions in a very direct way. There is also something profoundly humbling about this story. The atom, once thought to be the smallest unit of matter, turned out to be a complex system with its own internal structure and dynamics. And even that is not the end of the story. Inside the nucleus, protons and neutrons are themselves made of smaller particles. The deeper we look, the more layers we find. This suggests that our understanding of the universe is always incomplete, always evolving. The splitting of the atom is not the final chapter, but just one step in an ongoing journey of discovery. At the same time, it is impossible to ignore the emotional weight of this discovery. Imagine being one of the scientists involved, realizing that your work has led to something so powerful. There is excitement, certainly, but also a sense of unease. The knowledge that you have unlocked a force capable of immense destruction is not something that can be easily set aside. This tension between curiosity and consequence is at the heart of the story. It is what makes the splitting of the atom not just a scientific achievement, but a deeply human one. In the end, what began as a simple question about the nature of matter led to a discovery that changed the world forever. It reshaped our understanding of reality, revealed the immense energy hidden within atoms, and gave us the ability to harness that energy in ways both beneficial and destructive. It is a story that reminds us of the power of curiosity, the importance of questioning assumptions, and the responsibility that comes with knowledge. And so, what began as a quiet question about the nature of matter became one of the most powerful turning points in human history. The atom, once thought to be simple and indivisible, revealed a hidden world of structure, energy, and possibility. From the curiosity of scientists like Ernest Rutherford to the breakthroughs of Otto Hahn and Lise Meitner, each step brought us closer to unlocking a force that had always been there, quietly waiting within the fabric of reality. But what makes this discovery unforgettable is not just the science, it's what we chose to do with it. The splitting of the atom gave us a glimpse of something extraordinary, that even the smallest pieces of the universe carry unimaginable power. It taught us that knowledge is never just knowledge. It becomes action, consequence, and responsibility. It showed us that human curiosity can illuminate the darkest corners of the unknown, but it can also cast very long shadows. And maybe that's the most important part of this entire story. Not the equations, not the experiments, not even the explosion of discovery itself, but the realization that every breakthrough changes us. It asks something from us. It demands that we grow, not just in intelligence, but in wisdom, because in the end, the atom wasn't just split in a laboratory. In a way, it split our understanding of the world into a before and an after. Before, we believed we were observers of nature. After, we became participants in shaping it. So as you walk away from this, remember this simple but powerful truth. The future doesn't just depend on what we discover, it depends on how we choose to use it. Good luck on your journey of curiosity, wherever it takes you. Keep asking questions, keep challenging the obvious, and never stop exploring the unknown. And thank you for your time, your attention, and your willingness to think a little deeper today.